For this example here, we're going to go ahead and divide all of university students into male or female. Once again, pretending this whole sex dichotomy. And then we're going to divide those based on if they take loans out or not. So our first question here is, what is the probability that a student is male? And we can see from above that if I want the probability a student is male, well, I know 57% are female, right? So I'll just take 1 minus probability someone's female. And that'll be 1 minus 0.57 or 0.43. 43% of university students look like they're male. I want to make it really clear that I wrote down how I was doing the complement. Most of you probably did that in your head without even thinking about it in terms of it being technically a complement. That is, a lot of this probability stuff is actually second nature. We just don't think about using the formal language we're using in our course. Okay, aside from that question, our next one is, given a student is male, what are the chances they took out loans? And here we need to notice that we're not talking about all students. We're talking specifically about male students. So right here, I know I'm narrowing it down. So this is going to be conditional. Because I don't want to look at all students, I want to narrow it down to only dudes. So when I write this out, I'm going to write it using my conditional notation. This little bar, once again, means out of. And so in the back here, I need to talk about which category I'm narrowing it down to. And here, I'm talking specifically of male students. Now, out of the male students, I want to know how many of them took out loans. So this is the probability someone takes out loans out of all the male students. To find this probability then, I need to go ahead and on top, I could put the number who are male and took out loans divided by the number who are male, or I can just look up at the top there, and that is, it tells me, actually very clearly, up here at the top, that it's been shown 44% of female undergraduates take out loans compared to 39% of men. So actually at the top here, it's telling me out of male students, 39% of them take out loans. While this example ended up being super convenient, based on the fact that the question lined up with exactly what was given me on top, not all of them work out this nicely. And so what we want to do next is go ahead and talk about how we can find these same answers and more based upon creating a contingency table from the information I'm given.